This is question number 9, and we're asked to write an exponential function of the form y equals a times b to the x that contains two specific points. One of the points, x is 1, y is 10.5, and the other one, y is 3. I'm sorry, x is 3, and y should be 46.305. If I was to look at this, as a multiple representation, there's 2 points, but let's look at a table of values, right? So here's some x's and here's some y's. Well, one of the things I don't know when x is 0, I don't know what y is, but I do know when x is 1 that I hit the number 10.5. I don't know what value I get when x is 2, that's unknown to me, but I do know that when I get 3, I should get 46.305. So I've been setting these up, like a system of equations in which I write everything in except for the a and b, and I solve for a and b. But I'm looking at this. I know that it's geometric, because it's of this form, right? Y equals a times b to the x. So I'm multiplying by some particular value repeatedly. And when I look at this, I don't know what that number is, but if I multiply 10 by that number 2 times, I get 46.305. And in fact, that number is b. So if I multiply by b twice, let me make sure I get this right. If I take 10.5 and I multiply that by b and then by another b, I would have to get 46.305, right? So in this case, if you look at this, here's my answer, right? This is what I'm looking for, I think. 10.5 times b squared has to equal 46.305. So I can grab a calculator, and I think I can use that to find out what b is. By doing the following, I'm going to take b, I'm going to divide both sides by 10.5. So I get 46.305 divided by 10.5, and the square root of that is what b should be. So let me grab a calculator. Let's clear the screen, and I'm going to take 6 and then 0.305, and I'm going to divide that by 10.5. I missed the 1. I have to be honest, this virtual calculator is not working as well as it used to. I had to check out what happened here. 10.5. Okay, so I divide 46.305 by 10.5, and I get this number. And then I'm going to take the square root of that, right? So I want the square root of my last answer. And that gives me that b should be 2.1. So here I go. B is 2.1. Now this equation, actually b could be plus or minus 2.1. In this setting, clearly I'm multiplying by positive b. So what's nice about this is now that I think I know what b is, I can not only figure out what this missing number is here, but I can figure out what the one before that is. So for example, if I take 10.5, 10.5, and I multiply that times b, which is 2.1, I get that this value should be 22.05, which is just, it's a wonderful thing. I now think I know not only what the first and the third term is, but I think I know the second term. And going backwards the other direction, right? If I'm moving forward on this list, I'm multiplying by b. I can go backwards by dividing by b. In other words, there's some number such that when I multiply by b, I get 10.5. So if I take 10.5 and I divide that by 2.1, which is b divided by b, I get that my initial value is 5. So what's nice is now that I know what my common ratio is, right? I'm multiplying by b, which in each case was, what do we say, 2.1. Whoops, b is equal to 2.1. And now I know what my initial value is right here. This is a, right? When x is 0, this is my a value. I can write this function. So y equals a, which is 5, times b, which is 2.1 raised to the x power. Now it might be nice to go through and maybe enter that as a function and make sure it's producing the right values, but I think we've got our function. It's quite nice. And you know what, actually, just to double check my answer, I did enter this as a function. So y equals 5 times 2.1 raised to the x power. I could now take and go ahead and look at this as a table. And what I'm seeing here was when x is 0, I get 5. When it's 1, I have 10.5. When it's 2, I have 22.5. When x is 3, I have 46.305. So this function is doing an excellent job of producing these observed values, and importantly the two that I started with right here. So that's my answer to question number 9.